Hello everyone, this is Mr. Millen. I'm here today with the instructional video on the second transformation that we're discussing, which will be called a reflection. Now, the thing about reflections are you guys are already probably familiar with the word reflection because every time you walk by a mirror, right, you see your reflection. So the important thing about a reflection is in the coordinate plane is that the object stays the same size or shape. However, the pre-image and image will have been flipped across a given line. So with a reflection, all you're doing is you're flipping it across a given line. Now that might be the axis or some other line that it states, but you're flipping it across any line that it asks you to. So this can be thought of as looking at your reflection in a mirror or in something like water or, any type of shiny surface that you can think of, you can see your reflection. Okay. Now there is a little bit of a typo here that should say regardless of the reflection, not rotation. Okay, so regardless of the reflection you're performing in the coordinate plane, the pre-image and image coordinates will be an equal distance from the axis of reflection. Okay, and all the axis of reflection is the thing that it says to flip it over. Okay. Now, there are multiple types of reflections, but a few of them share kind of the same way that to approach it and to actually do the reflection. The first one of these is a reflection over the x-axis. Now, when you're looking at a coordinate plane, which way does the x-axis run? Well, the x-axis is going to run from right to left, and it's this line here. Okay, all the way across there, and it extends infinitely. Okay. Now the following rules apply when we do an x-axis reflection. The first thing is that the x-coordinate will remain the same. Okay, so you don't change your x-coordinate when flipping over the y or the x-axis. However, the y-coordinate will be transformed into its opposite. So for instance, if I told you that the y-coordinate was 5, it would transform it into its opposite, which would be -5. So to determine the opposite of a number, we just change the sign. So all we do here is change the sign. So this gives us the following mapping rule for a reflection over the x-axis. You have x comma y is mapped. The x-coordinate remains the same, so nothing happens to the x. The y-coordinate is transformed into its opposite, so that means that this was a positive y, then it would become a negative y, and vice versa. Okay. However, if you don't like formulas or whatever else, there's a simpler way you can do it. And you can measure how far your points are away from the axis to locate the new points. So for instance, if a point A is 6 units above the axis, then A prime, the image, will be where? Well, if you're 6 units above the axis, remember you're flipping it over it, so it can no longer be above, it be below, and they have to be equal distance. So the pre-image is 6 units above, then the image, A prime, will be 6 units below. Okay, below or under, whichever way you want to say it. So let's look at the diagram on the right for an example here. So we have triangle ABC here, and triangle ABC is going to be reflected over the x-axis. Now, when we do this, it doesn't matter which one you start with because you're going to have to do this for each one. So I'm going to start with A. Now, A is below the x-axis. So that means when we do A prime, it's going to end up being above. A prime is going to be above. So let's look. A is how many units away from the x-axis? Well, we count up 1, 2, 3, 4, 5. So the distance between it and the axis is 5 units. Now they have to be an equal distance, so this is 5 below. So this means that A prime will be 5 above at the same x coordinate. So 1, 2, 3, 4, 5. And of course, since this is the image, we label it with A prime. So both of those are 5 units away from the axis. Okay. Next up, you're going to look at B. How many units away is B from the axis? Well, if you look here, you can see it's 1 unit away. It's 1 unit below. So that means B prime. Oops. B prime will be 1 unit above in the same location. Then C, how many units is it away from it? Well, it is 7 units away from the x-axis, and it's below it, so C prime will be 7 above it. So C prime will be here. And then we just connect our points. Okay? So most of this stuff is just counting. Okay? So now let's look at a reflection over the y-axis. So this time, instead of looking at the x-axis, the horizontal axis, we're going to be looking at our vertical axis. Okay, so we're looking at this line here. So when reflecting points across the y-axis, the following rules apply. The y-coordinate is going to remain the same when you're doing this, so you're not going to be moving up and down. You're only going to be going left or right. And the x-coordinate is going to be transformed this time into its opposite. So that means our mapping rule for this, x comma y, it says the x is transformed into its opposite. So our first part is negative x. The y-coordinate remains the same. So that stays as y. And again, just like reflections over the x-axis, reflections over the y-axis can be said to be counted because it's the same distance. So for instance, if a point A is 7 units to the right of the axis, then A prime will have to be how many units away from the axis in which direction? Well, A prime will have to be the same number of units, so 7 units, and in the opposite direction from the original point. So that would be to the left, because the opposite of right is left. So let's look at an example here. We have triangle DEF, and we're reflecting it over the y-axis. Okay, so we're going to go straight to the y-axis from D. How many units away is D from the y-axis? Well, it is 1, 2 spots away, 2 units away. And D is 2 units to the left of the y-axis. So that means that you need 2 units to the right of the y-axis, and that will be D prime. Then you do the same thing for E. E is 1, 2, 3, 4, 5, 6, 7 away from the y-axis. So you have to go 7 in the other direction, starting at the y-axis, which would be here. And then F, F is 3 units away. So it's 3 units to the left, so your F prime is going to be 3 units to the right of the axis. And then you just connect your points. Okay. So reflections over the axis, all you're doing is counting the spaces and going from there. All right, so let's look at a little bit more, potentially more complicated ones. So here we're going to be doing a reflection over any line of the forms below. So that would be x equals a or y equals b, where x equals a is just some number over some number. So here it should say for any reflection over a horizontal line, this should be y equals b. Again, another typo, and this should be a or x equals a. So for any reflection over those types of lines, there's no general mapping rule, okay? So remember, x equals a number will be a vertical line, okay? The reason for this is the x has to stay the same. So for instance, if you say the line x equals 5, so if you are over here at x equals 5, no matter what y coordinate you pick, x must stay equal to 5. So that means that you're only going to be able to move up and down, not left and right. So x equals a number ends up being a vertical line. And then your y equals a number ends up being a horizontal line. And I do apologize for the typos in this. You know, I made this in quite a hurry, so, you know, I make mistakes quite frequently. All right. So the first point that you need to remember is that each point of a reflected image is the same distance from the line of reflection as its corresponding point from the pre-image. Okay, so all that's saying is that they're the same spaces away, just in opposite directions. And then 2, the line of reflection will lie directly in the middle between the pre-image and the image. Okay. So because of this, you can, quote unquote, count the distances that the lines have. Okay. So let's look at our example here. This example will wants us to reflect triangle KLM over the line y equals -2. And you'll notice here that this is y equals -2 because all the y values across that line are always -2. So you'll notice here, unlike the other ones we've done, that the shape itself crosses over this line, and that's okay. All that matters is that when you reflect it, the points end up on opposite sides of the line. So let's look at this. So if we have K, is K above or below the line of reflection here? Well, K is above, and it's 4 units above the line of reflection. So since this one's 4 above the line of reflection, then K prime, the image, needs to be 4 below it. So K prime, 1, 2, 3, 4, will be here. Now let's look at L. Now is L above or below the line of reflection? Well, L is below it. It's 2 units below it, in fact. So that means that L prime has to be in the opposite direction. So it has to be above the line of reflection. So it has to be 2 units above. So there's your L prime. And then M is 4 above the line of reflection. So M prime will be 4 below it. And then we just connect our spaces here. Oops, that's a terrible side. It'll do. You get the picture. Okay. So other than my terrible drawing, this would have the same size and shape. Okay. So just notice here, this is below, this is above, it crosses over that line. That's okay. All that matters is that they are equal distances away in opposite directions. All right, now let's look at the next ones that are more formulaic. So they require a formula, sort of. The first one is a reflection over the line y equals x. So when we reflect points across the line y equals x, the x coordinate and y coordinate switch places. So all we're doing there is we're going to switch the x and y coordinate. Okay, so the mapping rule is given to us by xy maps to, and we're going to switch our x and y coordinates. So that means y becomes the x and x becomes the y. So let's look at an example to see how this is done. So first off, we're going to find all the coordinates for r, s, and t, and then we're going to use our mapping rule to figure out where our reflection should be. So we have r is at -6, 3. S is at -1, 3. And t is at 1, 7. So in order to reflect this over the line y equals x, we need to make sure that we are only switching the x and the y. We're not going to change signs or anything like that. So let's look at r. So to reflect it over y equals x, we have to switch the places of the x and y coordinate. So all we're going to do is switch 3 and -6 around. So that means r prime is going to be 3, -6. Those 3, and then down 6 to give us r prime. So all we've done there, we've just switched them, done nothing else. So what would the coordinates for S be if we do the same thing? Well, we switch the x and the y, so S is going to be 3, -1. And then t, we switch the x and the y, and its coordinates become 7, +1. And then we just connect our sides, and there we go. So all we do with y equals x is we switch the places of the x and y coordinates. And our final type of reflection, this is going to be a reflection over the line y equals -x. So here's what happens when we do a reflection over the line y equals -x. The first thing is that the coordinates switch places, just like before. However, we do an additional thing with the signs. So you'll notice here y equals x was what we had before, but now we have a negative here. So not only are we switching places, but we're also changing the signs. Okay, so we're going to switch the x and y, and we're going to change the sign to its opposite. So this gives us the following mapping rule. X comma y maps to. We're going to switch x and y and then make them the opposite sign. So the x coordinate becomes -y and the y coordinate becomes -x. So let's look at our triangle here, our pre-image that we are going to reflect over y equals -x. So z is at the coordinates -6, +4. Y is at the coordinates -7, 0. and x is at the coordinates -2, -3. Now, when we reflect it over y equals -x, we need to switch their places and make the signs the opposite of what they were. So for -6, 4, if we switch the places and negate it, if we switch it, it becomes 4, -6, and then we change the signs. So the 4 becomes negative and the 6 becomes positive. So our z prime would be -4, +6. So -4, +6. So all we did there, we switched it and changed the signs. So now let's look at y prime. Y prime, you switch and then negate. So you switch the -7 and 0 and then change the signs on both. If you do a -0, it's still just 0. And then you do the opposite of -7, and that gives you 7. Our y prime would be at the coordinates 0, 7. And then our last one, point x. X prime, you're going to switch and negate. So you switch -2 and -3, then change their signs. So you get the coordinates would be 3, 2. Okay. And that's all the reflections, the different types, along with how to determine those. So we're going to look at some examples, and then you can work on the assignment. So when we look at these, we need to determine what our reflection is supposed to be. And then based on that reflection, we're going to determine our where to plot our points. So number 1 says a reflection across the y-axis. So we're going to be reflecting across this y-axis here. Now K, all our points are to the left of the y-axis, so all of our prime points will end up being right of it. K is 1 unit to the left of the y-axis, so K prime must be 1 unit to the right of the y-axis. So that's K prime. J is 2 units to the left of the y-axis. So J prime must be 2 units to the right of it. And then L is 4 units away to the left of it. So L prime must be 4 units away in the opposite direction. So number 2 says a reflection across the x-axis. So we're going to be reflecting across this line here. And all of our points are above the x-axis, so all of them will end up below when we do our prime coordinates. So we're going to start with W. W is 2 spaces above, 2 units above. So that means that W prime must be 2 units below. So this is W prime. T is 3 units above the x-axis, so that means that T prime must be 3 units below the x-axis. U is 5 units above the x-axis, so U prime must be 5 units below. And V is 4 units above the x-axis, so V prime must be 4 units below the x-axis. Okay. All right. So let's look at number 3. Number 3 wants a reflection across y equals x. So remember, when you're reflecting across y equals x, all you do with the coordinates is switch places. You switch x and y. So G is currently at 2, -1. H is at 3, -5. And F is at 1, -4. So G, you're going to switch places to find G prime. So you switch 2 and -1 around, and you get -1, +2. That's your G prime. Then F, you switch 1 and -4 around to give you F prime, and that's -4, +1. And then H is at 3, -5, so you switch the 2 coordinates around and you get -5, +3. And that completes our reflection over this line, y equals x. Number four says a reflection across y equals 1. Remember, when you have y equals a number, y equals is a horizontal line at y equals 1. So you go up 1 and then draw your horizontal line. So this is the reflection we're going to be, or the line we're going to be using for the reflection. So you have y here, y is below it. So that means that y prime is going to be above that line. So how many units away is y from the line y equals 1? Well, you have 1 unit of distance here, so y is 1 unit below, so that means y prime has to be 1 unit above. X is 3 units above y equals 1, so you have to be 3 units below for x prime. W is 4 units above y equals 1. So W prime needs to be 4 units below y equals 1. And V is 2 above y equals 1. So V prime has to be 2 below y equals 1. Number five says a reflection across x equals -1. Remember, x equals a number is a vertical line at that x value. So x equals -1 is a vertical line at x equals -1. So if we're looking here, we've got D, C, and E. They're all to the left of it, so our reflection will all have points to the right of it. There shouldn't be any overlap. So D is 1 unit to the left of x equals -1, so D prime must be 1 unit to the right of it. All right. Then C is 2 units to the left of x equals -1, so C prime must be 2 units to the right. And then E is 4 units away from x equals -1, so to the left, so E prime will be 4 units to the right of x equals -1. Okay. Number 6, it says a reflection across y equals -x. So remember, y equals -x, you're going to have to switch x and y and change the signs. So let's look at our coordinates for x. X is at 3, 0. W is at 5, 5. V is at 1, 5. And U is at 0, 3. So we need to do each one of these. We need to switch x and y and change the signs. So if we do x prime, we're going to switch x and y, so that gives us 0, 3, and then change the signs, which ends up giving us 0, -3. So 0, -3 is x prime. Then we're going to do u prime next. So we switch x and y, so 0, 3 becomes 3, 0, negate or change the signs on both of them, and it becomes -3, 0. V 1, 5, switch and change the signs, and you get 5 or -5, -1, excuse me. And then W, you have 5, 5. If you switch it and negate, you just end up with 5 or -5, -5 for W prime. Okay. There are 4 more examples here. If you feel like you have it, by all means, go ahead and work on the assignment. You can try these 4 out. If you are wanting to stay around, you can try these 4 out and then check your answers. But make sure either way that you work on the assignment. And if you have any questions, please let me know. So we're going to work out these last 4 here. 7, reflection across x equals -1. So x equals -1 is a solid vertical line here. So C, now you'll notice C is already on that axis. So that means that C prime is that same point. D is 1 unit to the right of x equals -1, so D prime will be 1 unit to the left. E is 4 units to the right of x equals -1, so E prime will be 4 units to the left. And B is 3 units away to the right, so this will be 3 units to the left for B prime. Number 8, reflection across y equals x. So you're going to switch x and y for this. So you have f at -2, 3, E at -4, 1, D at -3, -3, and G at, let's see, -2, 0. So we're going to switch these coordinates here. So F prime is going to become 3, -2. G prime is going to become 0, -2. D is going to remain the same, so it's still going to be D prime here. And then E prime is going to be 1, -4 after we switch it. Number 9, we want a reflection across the x-axis. So across the x-axis is this line here. Notice that D is below, so it's going to end up being above, and C and B are going to end up being below when you transform them. So there's going to be a bit of overlap here. So B is 1 unit above the x-axis, so B prime must be 1 unit below. C is 3 units above the x-axis, so C prime must be 3 units below. And D is 2 units below, so D prime must be 2 units above. And our last one, number 10, a reflection across y equals -x. So remember, you're going to switch x and y and change the signs. So T is at 1, 0. U is at 4, 2, and V is at 4, negative 3. So T prime, you're going to switch and change the signs. So that becomes 0, negative 1. V is going to become, you're going to switch and negate. So you're going to have 3, negative 4. And U, you're going to switch and negate, and you get negative 2, positive 4. Or sorry, negative 2, negative 4, excuse me. Okay. And that does it for this video. You know, work on the assignment. If you need help, please let me know. If you have any questions about this, you know, I'm always willing to help. Hopefully this video was helpful to you to learn the material with the reflections. Thanks, guys, and I will see you in the next video.